Hello students, today we are going to take up the topic method of preparation of chlorine and its chemical properties under group 17 part number 2 of E block elements in organic chemistry class plus 2. So let us start with a very good thought. Difficulties in your life don't come to destroy you but to help you realize your hidden potential and power. Let difficulties know that you too are difficult. Dr. APJ Abdul Kalam. So we need to face difficulties. Once we are facing difficulties, we are accustomed to the problems facing tendencies. So everything becomes easy afterwards. So learning outcomes from this session is we will be able to know about the preparation of chlorine from manganese dioxide and concentrated hydrochloric acid and from NaCl, MnO2 and concentrated sulfuric acid. These two are the methods. Apart from that, few other methods are also there. Reactions of chlorine, that is oxidizing action on reaction with H2S with chlorine, ammonia with chlorine, and cold and dilute NaOH with chlorine, hot and concentrated NaOH with chlorine. Along with that, we will discuss some uses and important questions. So let us start with first the preparation of chlorine. So chlorine was discovered by Scheele in 1774 and he named it as oxymuriatic gas, and sometimes hydrochloric acid is known as muriatic acid. So if you see the main reactants here concentrated sulfuric acid is used and here NaCl, MnO2. MnO2 here acting as oxidizing agent. Okay, so chlorine as such, you know that it is not available in the free state. It is always available in the combined state due to its high reactivity. And some of the minerals which contain chlorine are rock salt NaCl, sylvine, KCl, carbonate, corn silver, AgCl. Okay, so now coming to the main point here, basically the detail will not be asked in your exams, so they will be concentrating on the chemical equation. You should focus to write the balanced chemical equation correctly. So first is action of concentrated HCl on manganese dioxide. So as I have told you already, manganese dioxide acts as oxidizing agent which oxidizes HCl to chlorine. So here concentrated HCl is used, please take care of that. And in place of MnO2, we can use other oxidizing agents like lead oxide, Pb3O4, KMnO4 and potassium dichromate. So please keep in mind all these things. But as far as syllabus is concerned for ISC, these two only they have given in the syllabus. Others like PbO2, Pb3O4, KMnO4, potassium dichromate, this has not been specified in the syllabus. And second, action of concentrated sulfuric acid on sodium chloride in presence of manganese dioxide, we can write in the form of partial equation. If this reaction you know, NaCl plus H2SO4 concentrated, temperature less than 200, give rise to NaHSO4 plus HCl, and manganese dioxide, when you add in that, it will increase the rate of reaction also, and it will give us manganese sulfate, chlorine and water. So overall the equation would be NaCl plus MnO2 plus H2SO4 give rise to NaHSO4, manganese sulfate, chlorine and water. So you have to write the balanced equation whenever you are writing. So these two methods are there specifically mentioned in the syllabus. Now other, as I told you already, we can use KMnO4 also. Instead of MnO2, we can use KMnO4 also. We will get the chlorine gas. Okay. So as far as syllabus is concerned, they have not mentioned that, but we can cover that topic also. And along with this already we have covered KMnO4. And let us see lead oxide also, same manner, PbO2 plus 4 HCl give rise to PbCl2 plus water plus chlorine. So okay, so everything is same, only the reactant is different and heating we are doing, and concentrated hydrochloric acid we are using in each of the reactions, and here water is there to absorb this and to make it here. So what we are going to do is, if you are making hydrochloric acid, it's a chlorine gas. Chlorine gas will be coming here. To make it dry, we are using concentrated sulfuric acid here, and it will be collected. It is heavier than air, so it will be collected by upward displacement of air. Now, some reactions of chlorine we will like to take up. See, auto oxidation reduction. See here, if you see this reaction, chlorine plus water give rise to HCl plus HOCl. Here what are the oxidation numbers? See, chlorine is 0 because it is elemental state, oxygen is -2, chlorine is -1, and here chlorine is +1. So why chlorine +1 and oxygen -2? Because oxygen having the more electronegatividity. So which is more electronegatividity? It will be giving the, we are giving here -2 sign. Another would be +2. So +2 is divided into hydrogen and chlorine, H plus and chlorine plus. So this is the way how we are doing. Now the point here is chlorine 0, oxidation number changes to -1 here also, and chlorine changes to +1 also. The same substance undergo oxidation and reduction also. So this is the type of disproportionation reaction, and it's also known as auto-oxidation reduction reactions. Okay, so these are some important points which is used in each and every chapter of group 15, 16, 17, 18 of inorganic chemistry. Please do take care of these things which we are discussing now. Chlorine plus water give rise to HCl plus HOCl, hypochlorous acid, and this is unstable and it will again react with HCl to form nascent oxygen. So means to say that chlorine plus water gives us the oxygen. So it is acting as oxidizing agent, and oxidation or bleaching action of chlorine is due to oxidation. Now some reactions we are going to do with sodium hydroxide. These reactions are very important, and you see there are two reactions, hot and concentrated, and cold and dilute. So if hot solution of sodium hydroxide is there and concentrated, chlorine plus NaOH give rise to NaCl, and water is common plus NaClO3, means to say sodium chlorate. And previous second reaction we have already covered, that water plus chlorine give rise to HCl plus HClO, and HClO give rise to again HCl and oxygen. So ultimately we are getting the nascent oxygen or common. So the now point is this, as I told you already, hydrochloric acid is very unstable and the solution readily decomposes. The point here I want to discuss more. Let us see the next slide for that. See here, the chlorine with NaOH. This reaction we covered. Chlorine plus NaOH hot and concentrated. It give rise to NaCl and water. You see this reaction, cold and dilute also NaCl and water is there. What is the difference? The difference is with the NaClO3 and NaOCl. So here 0 oxidation number is there, and oxidation number chlorine -1, and here -2 +1 +1. So here it is +1 for chlorine. Chlorine we are talking of. And here also 0, 0 and -1, and here -6 +5. So now you see from here that here chlorine is changed from 0 to -1 and 0 to +1. The same manner here 0 to -1 and 0 to +5. So this is disproportionation type of reaction where the same element like chlorine is getting oxidized as well as reduced. And these two reactions are extremely important in view of the exams. It has been asked number of times. So basic thing we need to remember is NaCl and water will be formed in both cases, and only difference is NaOCl, hypochlorite, and sodium chlorate. Hypochlorite and sodium chlorate. Okay, so now if you are talking of reactions of chlorine with ammonia, there are two reactions. When ammonia is in excess, and on the other hand when chlorine is in excess. So if ammonia is in excess, let us say this ammonia is in excess, then we are getting ammonium chloride and nitrogen. Please keep in mind this, when you are keeping ammonia is in excess, ammonium chloride and nitrogen will be formed. We can write in this partial equation also, ammonia plus chlorine give rise to nitrogen plus HCl. And now see from here, the ammonia what is doing? Hydrogen is getting removed. Who is removing? Chlorine is removing. So chlorine is acting as oxidizing agent. And you know that oxidation takes place of what? Ammonia is oxidized to nitrogen. Removal of hydrogen is called oxidation. That's why chlorine is acting as oxidizing agent. So similarly, here also if you see, ammonia is changing into nitrogen. So removal of hydrogen takes place. Removal of hydrogen is called oxidation. Who is doing oxidation? Chlorine is doing. So this is the point you have to remember. And you see here chlorine is having 0 oxidation number, and here chlorine is having -1. 0 to -1 reduction is happening. So reduction happening, it means acting as oxidizing agent. So second reaction was chlorine in excess. If chlorine in excess, NaCl3 is forming. This is a yellow explosive liquid, nitrogen trichloride. Okay, and ammonium chloride is formed along with that. Now here you see chlorine, ammonia, hydrogen is moved and halogen is added. So here also oxidation takes place. Oxidation is addition of oxygen or electronegative element. Here hydrogen is added with chlorine. So that's why we are saying oxidation happened from ammonia to NaCl3. And who is doing? Chlorine. Chlorine is acting as oxidizing agent. Now some further reactions we can just see. Sodium plus halogen. Let us say I am taking chlorine. Na plus Cl give rise to NaCl. Now here see, sodium is having in elemental state 0 oxidation number, and here it is plus 1. 0 to plus 1 oxidation. Who is doing? Halogen is doing. Halogens are acting as oxidizing agent. Okay. Similarly here also the same thing. Hydrogen is changed to hydrogen halide, as hydrogen plus chlorine give rise to HCl. So what is doing? Chlorine is doing oxidation of hydrogen to HCl. Similarly, if you are taking here bromide and chlorine, and bromine is getting displaced. So why? Because chlorine is more reactive than bromine. So higher reactive element can displace the lower reactive element. So in the combined state also. Now see here, these are the further reactions we discussed just now, and see here P4 plus Cl2 gives rise to PCl5, and you see from here also 0 oxidation number changes to plus 5. So oxidation happened. Who has done? Chlorine. Chlorine is acting as oxidizing agent. So similarly here also 0 to changes to would be plus 1. So chlorine is acting as oxidizing agent. Here 0 to changes to 2. So oxidation, who is doing? Chlorine. Similarly 0 to plus 1. Chlorine is oxidizing agent in all these reactions. Okay. Now oxidation action of chlorine. So similarly here 0 changes to minus 1. 0 to minus 1 means reduction happening, but who is getting oxidized? Sulfur changes to minus 2 to 0. Minus 2 to 0 means oxidation. Who is doing? Chlorine. Chlorine is acting as oxidizing agent, but what happens? Reduction happens for chlorine. Okay. So similarly, these reactions also we discussed already. Chlorine plus water give rise to HCl plus HClO hypochlorous, and this is giving us nascent oxidant. So uses of chlorine: largely used for solution by municipal sewage, municipal supply water. Sewage treatment is not used as such, and used as bleaching agent in paper industry. Used in manufacturing dyes and explosives. Used in making PVC. PVC means polyvinyl chloride. Used in making industrial solvent like chloroform, CHCl3, carbon tetrachloride, CCl4, ethylene chloride. Ethylene means CH2, so hydrogen will be replaced with chlorine. Used in making refrigerant like France. Further to it is for making insecticides like BSC, benzene hexachloride, and DDT, dichloromethane, and used in making poisonous gases like mustard gas, phosgene, tear gas in warfare used in making bleaching powder, used in making hypochlorite, NaClO, chlorates, NaClO3. So you should remember that with cold and dilute what was formed, hot and concentrated what was formed. Here it is a link. Perchlorate, NaClO4, hydrochloric acid, used in extraction of metal like gold and platinum, and particularly HCl used for the pickling agent. So summary for that topic which we studied just now: chlorine prepared from manganese dioxide or KMnO4 or PbO2, PbO3 on treatment with concentrated HCl. Also chlorine can be prepared from NaCl, MnO2 and concentrated sulfuric acid. Oxidizing action of chlorine, which oxidizes H2S to sulfur, ammonia to nitrogen when ammonia is in excess, and ammonia to NCl3, yellow explosive liquid when ammonia is less or chlorine is in excess. On treatment of chlorine with cold dilute NaOH give rise to sodium chloride, sodium hypochlorite and water. On treatment with chlorine with a hot and concentrated solution give rise to sodium chloride and sodium chlorate and water. So let us test some questions so that how much you have understood the topic. Explain why in spite of nearly the same electron oxygen form hydrogen bonding while chlorine does not. Or we can say water is the liquid, HCl is a gas. Why? So both chlorine and oxygen have almost same electronegativity values, but the size of chlorine is larger than oxygen atom. Thus, charge density per unit volume means size is small, so volume will be small. So charge density means charge divided by volume. Volume is less for oxygen, so charge density is more. So water will undergo hydrogen bonding while HCl will not. Okay, so because of higher atomic size and lesser charge density. Now the next question is, how can you prepare chlorine from HCl and HCl from chlorine? So same here previously we discussed already, MnO2 plus 4 HCl concentrated give rise to MnCl2 plus water plus chlorine. Similarly, if you want to make hydrochloric acid, or chlorine plus water chlorides to HCl aqueous plus HOCl. Although HOCl is not stable, it will again give us chlorine, HCl and oxygen. Now the next is, why are halogens strong oxidizing agent? Please do take care of this, that this is also one of the important question. Halogens are having a general electron configuration of NS2NP5. It needs one electron to complete the octet because they are having low bond dissociation enthalpy and bond dissociation enthalpy or bond dissociation energy, high electron activity and large electron gain enthalpy. These are the reasons which makes it strong oxidizing agent. And they are having high tendency to accept electron, so therefore acting as a strong oxidizing agent. Now, which is the best oxidizing agent among fluorine, chlorine, bromine, iodine? So the answer for that is fluorine. Then how you can conclude that it's fluorine? It depends on the E0 value. E0 value means reduction values. Reduction values from for fluorine you can see it is 2.87, and if you see from iodine it is plus 0.62 volt. It means it is having tendency to reduction. So reduction means it is having tendency to gain electron. So gain electron means it will be helping in the oxidation, and it is acting as oxidizing agent. So more positive is the value of E0 reduction value and better is the oxidizing agent. So please do remember that oxidizing agent is not the criteria that the enthalpy, bond association. It is it is dependent on reduction values, and reduction value depends on three factors like bond dissociation energy, electron gain enthalpy and hydration energy. These three factors are deciding the E0 values for any oxidizing agent like fluorine, chlorine, bromine, iodine. Now hopefully you are knowing these answers, so congratulations to you for that. And let us repeat the thought. Difficulties in your life don't come to destroy you but to help you realize your hidden potential and power. Let difficulties knows that you too are different. APJ Abdul Kalam. Thank you.